Have you ever wondered why things fall down? It's a question that has intrigued humanity for centuries. From the moment we are born, we experience the pull of gravity, yet we often take it for granted. Imagine a world where objects didn't fall to the ground, where there was no force pulling us towards the earth. How different would our lives be? What keeps us grounded on Earth? It's not just a simple question, it's a profound mystery that has puzzled scientists and philosophers alike. The force that keeps us anchored to the ground is the same force that governs the motion of celestial bodies in the universe. This force is gravity, an invisible yet omnipresent force that shapes our very existence. Why does the moon orbit our planet? The moon's graceful dance around the Earth is a testament to the power of gravity. Without this force, the moon would drift away into the vastness of space. Gravity acts as a cosmic glue, holding celestial bodies in their orbits and ensuring the stability of our solar system. The answer is a fundamental force, gravity. This force is not just limited to our planet, it extends throughout the universe, influencing the motion of stars, planets, and galaxies. Gravity is the architect of the cosmos, shaping the structure and evolution of the universe. It's a force that governs the universe, from the smallest particles to the largest galaxies. Gravity is responsible for the formation of stars and planets, the creation of galaxies, and the intricate dance of celestial bodies. It is a force that operates on both the grandest and the most minute scales, connecting everything in the universe. Gravity is the force that pulls objects towards each other. Whether it's an apple falling from a tree or the Earth being pulled towards the sun, gravity is at work. This force is universal, affecting all objects with mass, no matter how big or small. It's like an invisible string connecting everything in the cosmos. Imagine a vast invisible web that stretches across the universe, linking every star, planet, and galaxy. This web is gravity, and it ensures that the universe remains interconnected and harmonious. Isaac Newton, a brilliant scientist, first described this force. In the 17th century, Newton formulated the law of universal gravitation, which states that every mass attracts every other mass with a force proportional to their masses and inversely proportional to the square of the distance between them. This groundbreaking discovery revolutionized our understanding of the universe. He realized that gravity is the reason apples fall from trees and the Earth revolves around the sun. Gravity is everywhere. It is a force that we encounter in our daily lives, yet it also governs the motion of planets and stars. Newton's insights laid the foundation for modern physics and astronomy. It's what keeps our feet on the ground. Without gravity, we would float away into the sky, untethered and adrift. This force gives us a sense of stability and security, allowing us to walk, run, and live our lives with confidence. It's what holds the Earth in orbit around the sun. The delicate balance between the gravitational pull of the sun and the Earth's inertia keeps our planet in a stable orbit, ensuring the regularity of seasons and the cycle of day and night. This balance is crucial for the sustenance of life on Earth. Without gravity, the universe would be a very different place. Stars and planets would not form, galaxies would not exist, and the intricate dance of celestial bodies would come to a halt. Gravity is the force that brings order to the cosmos, making life as we know it possible. It is the great pull that binds the universe together. Imagine an apple falling from a tree. Gravity pulls the apple towards the center of the Earth. This pull is why objects always fall downwards, not upwards. The Earth's gravity affects everything on its surface, keeping us from floating off into space. But gravity's reach extends far beyond our planet. It's the force that holds the moon in orbit around the Earth. The moon is constantly falling towards the Earth, but its sideways motion keeps it from crashing into us. This delicate balance between gravity and motion is what keeps celestial objects in their orbits. The strength of gravity depends on two things: mass and distance. Mass is the amount of matter an object has. The more massive an object, the stronger its gravitational pull. The sun, for example, has a much stronger gravitational pull than the Earth because it's much more massive. That's why the Earth revolves around the sun, even though they're both pulling on each other. The sun's gravity is much stronger because it's so much more massive. The farther apart two objects are, the weaker the gravitational force between them. This is why we feel the Earth's gravity much more strongly than the sun's gravity, even though the sun is much more massive. We are much closer to the Earth. Think of it like this. Imagine two magnets. When you hold them close together, they attract each other strongly. But as you move them farther apart, the attraction weakens. Gravity works the same way. Section 5. Weightlessness and Heavenly Waltz. In the vast expanse of space, gravity might seem absent. Images of astronauts floating effortlessly inside a spacecraft come to mind, but gravity is still very much present in space. It's what holds the International Space Station in orbit around Earth. Astronauts appear weightless because they are in a state of continuous freefall. They are falling towards Earth at the same rate as the spacecraft, creating the illusion of weightlessness. It's like being in an elevator that's constantly falling but never crashes. Section 6. Gravity's influence from sports to structures. Gravity plays a crucial role in our everyday lives, often in ways we don't even realize. It is a force that is constantly at work, shaping the world around us and influencing our actions and movements in subtle yet profound ways. It influences the trajectory of a basketball thrown towards the hoop, determining whether it swishes through the net or bounces off the rim. Players must calculate the perfect angle and force to counteract gravity's pull. Similarly, the arc of a soccer ball soaring through the air is a dance with gravity. The player must strike the ball with precision, considering both the power and the spin to achieve the desired flight path. And who can forget the thrilling descent of a skydiver leaping from a plane? As they freefall, gravity accelerates their descent until the parachute opens, creating a delicate balance between gravity and air resistance. In sports, athletes learn to work with and against gravity. Runners and cyclists, for instance, must overcome gravitational forces to propel themselves forward, using their strength and endurance to maintain speed and momentum. Weightlifters, on the other hand, harness gravity to build muscle and power. By lifting heavy weights, they challenge their muscles to grow stronger, using gravity as a constant resistance. Gymnasts and skateboarders must master their movements to account for gravity's pull. Every flip, twist, and trick requires precise control and timing to ensure a safe and successful landing. For example, a high jumper needs to overcome gravity to clear the bar. They must generate enough force in their jump to lift their body high enough, while also coordinating their movements to glide over the bar without knocking it down. But gravity's influence extends beyond sports. In the world of construction, engineers and architects must consider gravity when designing buildings and structures. Skyscrapers, bridges, and even simple houses are all built with gravity in mind, ensuring they can withstand the forces acting upon them. The materials used, the foundation laid, and the overall design all play a role in how well a structure can resist gravity's pull. Without careful planning and consideration, buildings could collapse under their own weight. Even in space, gravity's influence is felt. Satellites orbit the Earth due to the delicate balance between their forward momentum and the gravitational pull of our planet. Astronauts aboard the International Space Station experience microgravity, allowing them to float and conduct experiments in ways that are impossible on Earth. From the simple act of dropping an object to the complex calculations required for space travel, gravity is a fundamental force that shapes our world. Understanding its influence helps us navigate our daily lives and achieve incredible feats, both on the ground and beyond. Section 7. Harnessing Gravity, Engineering Marvels. Engineers and architects take gravity into account when designing buildings, bridges, and other structures. They need to ensure that their creations can withstand the constant pull of gravity, keeping people safe. The towering skyscrapers that grace our cities, the majestic bridges that connect landmasses, all stand as testaments to our understanding and mastery of gravity. Gravity is not just a force, it's a tool that we've learned to harness. Section 8. Gravity's Grip on Life. Gravity's influence extends to the very essence of life itself. Our bodies have evolved to function under Earth's gravity. It affects our bone density, muscle strength, and even our cardiovascular system. Without gravity, our bones and muscles would weaken, our sense of balance would be thrown off. Gravity, in a sense, helps to keep us grounded, both physically and metaphorically. Section 9. A world without gravity. Imagine for a moment a world without gravity. Picture yourself waking up one morning, and as you step out of bed, you find yourself floating towards the ceiling. The sensation of weightlessness would be both exhilarating and terrifying. What would happen? Objects would no longer fall down. Everyday items like your phone, books, and even furniture would be suspended in mid-air. Streets would be filled with floating cars, bicycles, and pedestrians all drifting aimlessly. We would float effortlessly in the air. The oceans would drift away into space. Imagine the vast bodies of water no longer held by gravity, rising and dispersing into the atmosphere, creating a surreal and chaotic scene. Planets would cease to orbit stars, and the universe as we know it would cease to exist. The delicate balance that keeps celestial bodies in their paths would be disrupted, leading to a cosmic disarray. Stars, planets, and moons would drift aimlessly through the void. Gravity, while often unseen and unappreciated, is the glue that holds our universe together. It is the force that binds galaxies, forms stars, and creates planets. Without it, the night sky would be an entirely different spectacle, devoid of the familiar constellations and celestial wonders. It's a force that shapes our world, influences our lives, and inspires our curiosity. From the majestic mountains and deep valleys to the bustling cityscapes, gravity gives structure and form to everything we see. It affects the way we move, the way we build, and even the way we think about the universe. So the next time you see an apple fall from a tree, take a moment to appreciate the invisible force at play: gravity, the hidden force behind everything. This simple act, observed by Sir Isaac Newton, led to the profound understanding of gravitational force, a concept that has shaped scientific thought for centuries. Gravity is not just a force, it's a fundamental aspect of our existence, influencing every moment of our lives.